Okay, Algebra 2, let's get ready for this test. Let's look at number 1. I don't think you can see actually all of this problem, but it says write a function rule that produces an output of 28 for an input of 4. So we're going to just start. A function rule is just another way of saying equation. So we're going to have an equation, y equals something with x in it, okay? So we've got an x and a y in our equation, so that's looking good. Now, my input, that means it's my x, is going to be 4, and I need to change that into a 28. Well, how would I change a 4 to a 28? Lots of different ways. But I'm going to say that the easiest way to do this is just to add 24. So that's what I would do. Y equals x plus 24. Now, you certainly could say y equals 7x. That would work, okay? But just in general, just adding something or subtracting something is going to be a pretty easy way to do that. Let's look at the next one. Let's see, y equals x plus 24. Number 2, the local pizza place charges $14.50 for a large one-topping pizza. Each additional topping is $1.25. Okay, so now here's what I see. I see the word each, okay? Each, every, and per mean to multiply. So this is just keying me in that I'm going to need to multiply $1.25 times each topping. Okay, so let's write a function to model this situation. This is going to be $14.50 plus $1.25 for each topping. And actually what I'm going to do, I'm going to change my mind. I'm not going to use t. That's going to get confusing and look like a plus. Plus $1.25 times x. How much is a large pizza with 4 additional toppings? So now I'm going to put 4 in for x right here. And so I'll have $14.50 plus $1.25 times 4. And that is going to be $19.50. Okay, so the first thing I have to do is write a function. That's that. Second thing I need to do is answer the rest of the question, and that's going to be $19.50. All right, number 3. Mr. Reynolds is a car salesman. He makes a salary of $43,000 a year and also earns a commission of 1/8 of his total car sales for the year. So he makes $43,000. And also, so that's going to be a plus, 1/8 of his total sales for the year. Okay? Right? And evaluate a function. So that's what it is. So let's say that his wages, his earnings, I'll just say wages, is equal to $43,000 plus 1/8 of his sales. That's the function. Okay? Now, I want to know his sales total is $315, so we're going to take $315,000 and put it in for S. So it's $43,000 plus 1/8 times $315,200. And let's see what that comes out to. 43,000 plus 1/8 times $315,200. That's going to be $82,400. $82,400. That's the second part of that answer. So the first part, it says write and evaluate a function. So that is writing the function right there. Evaluating the function is $82,400. Okay. Number 4, the line y minus 3 equals 7 times x plus 4 contains the point A8. Find A and show your work. Well, A is our x value, 8 is our y value. So if we just sub those points back in here, the 8 is y. So this is going to be 8 minus 3 equals 7 times the x value we said was actually going to be A plus 4. Okay, so on the left side, 8 minus 3 is just 5. And on the right side, when I distribute that, that's going to be 7a plus 28. Well, let's solve that. Subtract the 28 over. And 5 minus 28 is going to be negative 23 is equal to 7a. And then divide by 7, and a is just going to be equal to negative 23 divided by 7. Okay, now I'm not sure that looks right. Let me just double check my work here. 7a plus 28. That's it. Okay, so it is a fraction, and that's going to be okay. Let's look at number 5. The equation y minus 5x equals 7 models the number of pages y you finish reading in your textbook after you read it for 8 hours this week. Write this equation in slope-intercept form. Slope-intercept form is y equals mx plus b. All right, a lot of times we'll see this y equals 3x plus 2, something like that. So we've got a y equals, we have to solve this for y, and then we've got a 3 times x and then something else. So if I have this equation up here, y minus 5x equals 7. If I want to solve that for y, all I need to do is add the 5x over, cross the line, change the sign, and then if I want, I could write this and put the x up front, and so this would just be y equals 5x plus 7, and this is slope-intercept form. Okay, now letter B. What's the slope? Slope's the number in front of x, so that's going to be 5. What does the slope represent? Well, let's see what it was. X is hours, and y is pages that you finish reading. So slope is always going to be a rate. Miles per hour, dollars per pizza. I like that one. Something like that along that line. In this case, it's going to be pages per hour. And so the 5 means that you read 5 pages per hour. Let's look at the next one. Letter D. What does the point 742 represent in this situation? Well, we already know that 7 is our x value, and x is hours, so that's going to be 7 hours. 42 is our y value, which is pages. So here's what it means. After you've read for 7 hours, you've read 42 pages. Okay, 7 hours, 42 pages. Number 6. The table below shows the number of hours that the students spend studying for a math test, the grade, and the grade that they scored. Use a calculator to find the line of best fit. Okay, so what we're going to do, this is a scatter plot. I'm just going to pick the first and the last one and make the line of best fit. So we will use the ordered pairs 162 and 683, and then find the slope, y minus y over x minus x. 62 minus 83 over 1 minus 6. That's going to be negative 19 over negative 5. And when I divide that, negative 19 divided by negative 5, that's going to be positive 3.8. So that's our slope. Okay, so we're going to have y minus y. So y minus 62 equals 3.8 times x minus 1. Distribute this. 3.8x minus 3.8. Y minus 62. Last step, add the 62 over, and we're going to have this equation here. I'm going to write it in red so that we don't lose it. So we're going to have, when I add the 62 over, y equals 3.8x plus 58.2. That's our line of best fit. Okay? Letter B. Use your linear model to predict the score if someone spends 4 hours studying. Well, 4 hours, that's our x, so all I have to do is put 4 in for x in that equation, and let's see what we get. So we get 3.8 times 4 plus 58.2 equals 73.4. 73.4 is the answer. Okay, let's do letter C. Use the linear model to predict the amount of time spent studying if someone scores an 87%. So 87% is our score, that's our y. So we just need to put 87 in for y in that equation. 3.8x plus 58.2. Well, we know how to solve this. All we have to do is cross the line, change the sign. Subtract the 58.2 and then divide by the 3.8. So subtract 58.2. 87 minus 58.2 is going to be 28.8. Last step, divide by 3.8. And that's going to be 7.57. Okay, so about 7.5 hours. About 7.5 hours studying to get that 87. Letter D, will your linear model work for someone who spends 15 hours studying? Well, I don't know. Let's see if it does. Let's put 15 in for x, so 3.8 times 15 plus 58.2. Let's see what that is. 3.8 times 15 plus 58.2. That's going to be 115.2. So is that logical? Can you score 115 on the test? No, you can't. All right, so that will not work because you can't score more than 100% on the test. Okay, number 7. You want to buy some CDs that cost $6 each and some DVDs that cost $10 each. You have $90 to spend. Letter A, write an inequality to represent this situation. So where X is the number of CDs you buy and Y is the number of DVDs. Okay, so this is each and each. Each means to multiply. So I need to multiply 6 times the number of CDs, which down here it says is X. So 6X. We're also buying some DVDs that cost $10 each. So that's going to be 10 times, in the problem it says Y is the number of DVDs. And we have $90 to spend. Now, it needs to be an inequality. So what we spend has to be less than or equal to what we have. So we have 6x plus 10y equals 90. Okay, so that's letter A. That's our inequality. Letter B, we're going to graph this. Well, let's think about this. If I would only buy CDs for $6 each, how many could I buy? I could buy 15. So let me see. CDs are going to be down here. I'm going to go over to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that was 15 right there. So I could buy 15 CDs. How many DVDs could I buy if I only bought DVDs? Well, $10 each, 90 divided by 10 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I could buy 9 DVDs. Okay? Now I need to graph this. So I need to draw a line between them. And this is going to be a solid line because this is less than or equal to. So it's a solid line. And since it's less than, I need to shade below. Okay. Letter C, why did the graph in B only include quadrant 1? Well, if I would make this whole graph right here, just like this, so it looks like a normal coordinate plane with all 4, you'd see it's only up in that first part. And the reason is because all the other parts are negative, and we can't buy a negative numbers of CDs or DVDs, so they have to both be positive. Letter D, can you buy 5 CDs and 4 DVDs? Well, let's see. Let's look at the graph first. If I go over to 5 CDs, 1, 2, 3, 4, 5, and 4 DVDs, that's that point right there. Let me make it in blue so it's easier to see. Right there, that point right there. Can I buy that many? Well, I'm not always a big fan of trusting graphs, but it's very clear to see that that blue is in the shaded area. It's less than the amount that we have to spend, so yes, we certainly can. Another way to do this is you could put 5 and 4 back into our equation. 6 times 5 CDs plus 10 times 4 DVDs. Is that less than or equal to 90? 30 plus 40, that's going to be 70, is definitely less than or equal to 90. So we can. All right, number 8. Write an absolute value inequality for which the boundary is dashed and the shaded region is below the boundary. So we need absolute value, inequality, so it's going to be like a less than or greater than. We'll figure that out later. Okay? The boundary has to be dashed, which means there's not going to be an equal sign with this. And the shaded region is below the boundary. Well, how do I make it below? it needs to be less than. So less than is going to pull it below. All right, number 9. A school system is buying new computers. They will buy desktop computers for $1,000 per unit and notebook computers costing $1,200 per unit. The total cost of computers cannot exceed $80,000. Write an inequality that describes the situation. Okay, so let's say that desktop is D and notebook is N. Okay, so I see per right here. Remember, every and per mean to multiply. So I'm going to have 1,000 times D, $1,000 per desktop, plus $1,200 per notebook, and it cannot exceed. That means it's got to be less than or equal to 80,000. If it can't exceed, it could be less than 80,000. It could also be equal, but it can't be more. So graph this inequality. So let's talk about this. How many desktops could I buy? If it's 80,000 and $1,000 for each desktop, if you take 80,000 divided by 1,000, we're going to get 80. So I'm going to come over and say if I only bought desktops, I could buy 80. Okay, what about notebooks? If I take 80,000 divided by 1,200, because each one is $1,200, that's going to be 66 2/3. So 66 desktops is what I could buy if I only bought desktops. So now let's just connect these two dots right there. And since it could be less than or equal to, I'm going to keep it a solid line, and less than is going to be shaded below. So that's the graph. Okay, letter C. If the school wants to buy 50 desktop computers and 25 notebook computers, will they have enough money? Well, let's look. So here's 50 desktop, 25 notebook is right here, and as I look, okay, it's definitely in the shaded area in my graph, but again, I don't trust graphs all the time. So let's look at this back in our inequality and see if it works. So my gut says yes, but we'll see. 1,000 times 50 plus 1,200 times 25, is that less than or equal to 80,000? Well, I really don't know. So let's see. 1,000 times 50, okay, that's just going to be 50,000, plus 1,200 times 25. What does that equal? That equals 80,000. Okay, so 80,000, is 80,000 less than or equal to 80,000? Yes, it is. It's equal to. So I guess my graph was just a little bit high because that showed up exactly on that line then. So we sure can do it. All right, let's keep rolling. Describe each transformation. So we're just looking for the number out here. That plus 7 at the end is just going to make it go up 7. The next one, this minus 2 inside with the x. Remember, x's are liars. They're backwards. So instead of going minus 2, it's going to go plus 2. So we're going right 2. And then this plus 4 means going up 4. Right 2 and up 4. Okay, this next one. So the negative out in front of the absolute value, it's like, that's kind of like the slope, right? Normally, if it's a positive slope, it's going to be going up. But since this is negative, it's going to be a negative slope going down. So it flips it from up to down. We're flipping our x, or reflecting the x. So I'm going to say we're reflecting our y value, because the y is what goes up and down. So we're reflecting the y. I would also say that if you wanted to just say we're flipping it down, I would take that. All right, it's maybe not the best way to say it, but I understand what you're saying. And then also that plus 6 means we're going up 6. Okay, write the equation of each function. Okay, let's see what we've got here. So this is going to be y equals x squared. That's the shape of a parabola. And it looks like we moved it right 3 and up 2 to get that dot there when it started at 0. So to go right 3, how are we going to have to change this? Well, we're going to have to go, remember, x's are liars, so this is going to be a negative 3 squared. X minus 3 squared, that's going to move it 3 to the right. And then to go up 2, we just need a plus 2. Okay, let's look at this one. This is definitely an absolute value because it makes AV. Remember, absolute value makes AV. Okay, so first thing we did, it looks like we scooted it to the left 3, okay? So that's changing the x. X's are liars, so it's not going to be a minus 3, it's going to be a plus 3. And instead of that graph going up, it's going down, so we're flipping the y value, so that's going to be a negative out in front. Okay, so next one, that graph is definitely y equals x to the third. And our point is at 3, and you can't even see it, but if you look at that, 4, 3, 2, 1's going to be down here, 0 is going to be back here. I actually moved that 3 spots to the right. So how do I move that 3 spots, that x, 3 spots to the right? Well, x's are liars, so it's not going to be a plus 3. It's going to be a minus 3. X minus 3 to the third. All right, I know this was a long video, but tests are pretty important. Make sure you know everything that's on here because it is going to be on the test. All right, I know you got it. Good luck.